Hi everyone, in this video we're going to talk about how to get positive and negative voltage from a single tap transformer. What I got here is basically kind of a single tap transformer. I got 0, 16.4 and 19.3. I'm only using a 19.3 volt out, and basically as it stands is just a single tap. There's no center tap transformer here. It's just we got 0 and our output. So how to get to say, for instance, I want to run a device that needs a plus and minus 15 volt at say around 400 milliamp. How do we going to do that? We're just using a single transformer. So let's see what we can do here. We got many different ways to do that. I wanted to stick into linear type. I don't want any switching device in my project, because switching obviously is going to be generating a lot of noise and stuff like that. And you can get rid of the noise if you have proper capacitance and add capacitance and inductors to kill all the noise or the switching noise on the. See if I'm going to go to a switching type inverter, but then design a PCB for that, because the ground loop and how you design the PCB for switching regulators matters. But I don't want to go through that. I just want it to be plus and minus 15 volt at around 400 milliamp and low noise. So what I'm talking about low noise, say less than 15 millivolt or 10 millivolt of ripple on the output. So just to talk about, obviously we can use the Jelly Bean IC, which has been around for ages, the MC340663, which is either a step up or a step down, or inverting IC. It can't produce on its own 400 milliamp on the output, but we can add additional output pass elements like a transistor or a MOSFET to boost the current. But as I said, I don't want to go in that route. We have another circuit here, which obviously if you have a square wave or a sine wave or anything, usually is a square wave, and you got this kind of like a charge pump circuit here with 2 capacitor and 2 diode, and you generate a negative rail on the output. This not only generates a negative, it also boosts the voltage as well. So whatever input you have here, you get double the output there. But the problem with this is no way that it can produce that kind of a current, especially if you're generating your square wave from I don't know, from a 5 volt microcontroller, or 5 timer. So if you got 10 volt, 12 volt, there's no way that it can produce that kind of a current that we require for our specs. So this is the transformer I have for all intents and purposes, 240 and say 20 volt and 1 amp. The transformer I think is good for 1.5 amp, but let's just say it's 1 amp, so we can do our plus and minus at 400 milliamp that we want. So how do we go? What do we design? What kind of circuit we have to design to go and produce a negative rail with just a single output on our transformer, but have a low noise and stay in the linear region? So what comes to mind? Okay, so we're gonna take advantage of this, and you see in a minute why. So if I just forget about everything else for now, and this is the circuit we were talking about here. And the good thing about this is, because our transformer is kind of not a signal generator, but it's kind of generating some form of signal on its output, and that is the 50 hertz. Okay, so the AC goes in and the AC comes out. The frequency is very low. Usually when you get a switcher, the frequency is into kilohertz, hundreds of kilohertz. So you can switch your inductor to provide either a boost or a buck or inverting. But in here we have 50 hertz. So how can we use that 50 hertz signal to create our negative rail? And it needs to be linear. We don't want any switching stuff. Because that's switching at 50 hertz, we can feed it into our charge pump, as we discussed before, and that's gonna boost our signal, boost our voltage, and generate a negative rail. But as we discussed, there's no way this can maintain 400 milliamp. But the good thing about it is, if we use a high enough capacitor, the first capacitor that we have, if we use a high enough capacitance, then that installs a lot of charge on it that pushes to the other side to generate, to give us the current and get our negative. So by using a large-ish capacitor here, we can accommodate the 400 millivolt that we need for our current, for 400 milliamp that we need for the current, and we need to obviously somehow bring the noise down. So we're going to stick a really large capacitor at the very end of it, 6800 microfarad capacitor, and that should reduce our ripple that comes out of here all the way down. And then what we're going to do after, we're going to, because our voltage is doubled and we only want 15 volt, we need to have some form of pre-regulator, because we can't put 40 volt into our linear regulator. I think the maximum these guys can handle is maybe 30 odd volts. So 40 volt is going to be quite high. So what we're going to do, we're going to kind of pre-regulate this with a PNP transistor and a Zener diode to bring it down a bit, because we don't want to put all of that stress into our linear regulator. And then we're going to feed that into our linear regulator to get our 15 volt out. So what we're going to do, we're going to look at the scope, and we're going to look at some points here and do some measurements and tests and see what kind of a ripples and what kind of noise and stuff do we get here, and if there's any point of choosing this over a switching regulator and stuff like that. So we're going to discuss what I mean by using a large capacitor here. Why do we have this kind of orientation of diode? What's the point of this large capacitor? We're going to look at our kind of a pre-regulator, and we're going to look at the output of our main regulator, and we're going to kind of look at a quick way of what the principle of this is. And we're going to also look at a noise of a switching regulator and see the difference between this and between a switching regulator. Okay, so what I got here, if it's visible, yep. Okay, so I've got a kind of a switcher regulator here, but obviously it doesn't have a controller, it doesn't have any form of feedback. All I'm doing is I'm feeding a signal from my signal generator, and we have got a power supply, and we're going to see what kind of a voltage do we get. So if I put that up, and let's see. Okay, so what voltage do we have going into our system? Okay, let's see here. So we got, nope, that's the right. What do we got here? Nope. All right, here. That's not right either. So what do we have here? We should be getting over here. Yep, that's correct. And that's a negative. That's fine. What do we get over here? Okay, something is not right here. And let's see why that's not right here. Okay, what's going on here? Let's see. My wires are all gone all the way around. Good. Okay, yeah, that's what the problem was. Alright, so we got 5 volt going into our system. The silly power supply was in protection mode for some strange reason. When you want them to work, it never works. Alright, so we're feeding our power there. And let's see, what do we get? Okay, so we got 5 volt, about 6 volt going into our system. Let's make it 5 volt. There we go. Okay, 5 volt going into our system. And what do we get out? Okay, we need to put our signal gen on. And we get around 40 way. Let's bring that down. Okay, let's make it into 20. There we go. It doesn't matter. Okay, so we got around 25 or whatever it is out on our boost converter. So what do I have here? I got signal going from my signal gen. Okay, we got 10, we got, let's bring it down. There we go. Up to down here, and the signal comes down. There we are. So I have around 400 kilohertz going into our little switcher inverter here, basically, and we are inverting the signal, and basically we are producing minus 33 volt on the output. Okay, now I'm gonna look at the ripples on this, and the way we look at ripple is a proper way of doing. We don't want to use our silly ground lead, which is acts as an antenna. We're going to do a proper professional. We're going to have a BNC, and we're going to have our probe like so. I know this is on a breadboard and it's going to be a lot of noise and everything running around here, but that's just beside the point now. I just want to do, we're going to do our bit to make sure everything's fine, and we're going to make sure that we are getting something on the output. And let's see, what do we get? All right, so if I measure again, let's see, what voltage do we get? Okay, so we are at minus 33 volts. And if we look at the ripple on the output, and what do we get? We got around 70. So let's go here. There we go. We got around 70, around 80 millivolt of ripple. And this is without any loads. Okay, you need to remember that, without any load. As soon as we start putting load onto it, it's going to affect it drastically. So let's see if we can put a load to it and see what do we get with the load. My dummy load is not going to be able to take care of this because this is high voltage. But if I just put a capacitor resistor here, what do we get? Okay, you see that this is completely gone. Our negative rail is completely collapsed, and basically everything is going to doolally. Okay, so let me just get kind of a largish, and let's see what do we get with the 220 ohm. Okay, that's dropped a lot as well. That's not gonna handle it. Okay, let's bring that even further up. Let's see, what do we get with that? Nope, that's completely gone as well. So I'm gonna put a 1K, and let's see, what do we get? Okay, there we go. So our negative voltage has dropped to 12 volt now, and we are getting, okay, I'm in high res mode, and it is telling me, let's go to auto run this and turn that off. We don't need that. I'll bring that down. There's our voltage disappeared to now. Okay, why is it on DC mode? On AC, we want to 20. Whoa, it's gone crazy. Bring it down here. Okay, now you can see the noise. Alright. Alright, yeah, we're around 50, and you can see all of that nastiness on our circuit, and we don't want that. We don't want any of that stuff in my circuit. Okay, we don't want any of this switching stuff. 70 millivolt, something like that. No. Okay, that's the whole reason that I said I want to stick to a linear type. I don't want any switches in my device, and we want to use a transformer and get a nice output. Okay, so let's see what we're gonna do. So I'm gonna turn these off now, and we're gonna go into our transformer base and see what kind of thing we can do to get our output from a single rail transformer. Okay, so let me just move things around and we get back. Okay, so now we're gonna connect our transformer, and I'm gonna turn that off. I need to be careful here, don't want to electrocute myself. Okay, so in the UK we got 240 coming from our mains. Okay, 240 going in, and let's see what do we get on our AC out. Okay, let's see here, we got AC, and let's see how much exactly. It says 19.3, but let's see what do we get. Yep, 19.2. I'm happy with that. Okay, so this is the circuit that we're gonna have a look at. Okay, what is it flashing for? Okay, so we're gonna look at this. All right, so we're gonna look at that, and we got our transformer coming here that way, and we're gonna take a look at this. I'm gonna probe certain points here, and then we're gonna put a load on it and see if it holds up and see what kind of a noise we get on its output. All right, so let's see the circuit that I've got here. Okay, because our voltage differences are quite high, I've put these on the heatsink so we don't stress, because we're going to be loading it. I'm going to have a look around, so we don't want this to get hot. And what we got here, we got our positive 15 volt regulator here to give us positive 15 volt, and we got all of this stuff here, and this is our kind of a pre-regulator, and this is our 7915 to give our negative out. All right, so we're going to put these here, and I'm going to connect. There we go. See, here we go. And I'm going to connect our things out here. So one goes to a diode here, and one goes to one over there. Okay, and we're going to have a quick look at what do we get. So to connect here, and let's see. So we got a single tap on our transformer going into our circuit here, and we got our 15 plus 15, and we got our negative 15. Okay, it's a bit high. That's to do with the voltage regulator. Not all of them are exactly 15 volt, but yeah, minus 15 point and our plus 15. Okay, and what do we have here? The only thing different in this circuit here, that I've got a power resistor here to bring the voltage down a bit, because the voltage obviously is going to get doubled here. So I've put this just to bring the voltage down. I don't want to stress the items here. So we got our 1000 microfarad capacitor here. We got our 2 diodes there. We got our bulk capacitor 6800 here. Then it goes into our first pre-regulator here, which is down there, and then it goes into our voltage regulator with capacitor, and then this is our Zener diodes here to bring the voltage down from our first stage, basically to bring it to about 30 volts. Okay, so let's see what voltage do we get to the input of our regulator down there. Where is the input gone? Okay, so here we get about 30 volt going in. What voltage do we get on the output? As you can see here, so we had about 20 volt. Okay, so if I measure here, we get about around 19.2 AC going into our system, and we get around 50 volt out. So it's not only multiplying it, it's not 2, it's more than 2. So 2 point something is being multiplied. So we got 50 volt here. Okay, and what is this one on? Oh, it's just on the boundary of this is a 50 volt as well. So I just need to make sure, be careful that it doesn't surpass its maximum voltage. Okay, so we got minus 50 volt here, and minus 50 volt goes into our kind of a pre-regulator, and we get minus 30, so it's dropping around 20 volt. And then that obviously 30 volt is safe for our 7915, and then we get our minus 15 volt out. All right, as it stands, let's look at kind of a ripple, what kind AC we get here. So we get about 8 millivolts of AC component on the output of our linear regulator. That is brilliant. That is really, really good compared to what we were getting before with our switcher. This is really, and bear in mind that this is on a breadboard. So once you put this on a proper PCB and you design it properly, it's going to be rock solid, and you're going to get really good result compared to the switching regulator. Okay, now what we're going to do, we're going to put our load over here. So we're going to put this one to another side so we can get everything in one shot if I can. There we go. Hey. All right, so just need to be careful, don't blow things up. Wait, something went funny. What was that? Okay, so that's visible. Now what we need to be careful is, because we are going to put a load on a negative rail, we need to flip these around. These are designed only for positive. So what we're going to do is we're going to treat our ground as a positive, because it is, and we're going to treat our output as our ground, and then it works perfectly fine. A lot of people might not know this, but that's if you flip them around, you can still use this to measure negative rail as well. Okay, so let's go down to 100 millivolts. Okay, our ripple is climbing. 16 millivolts, 17 millivolts, still perfectly fine. 200, 27 millivolts, and 400, about 50 millivolts it says, but I think it's to do with what we got here, because it's on a breadboard. This, I don't think it's got to do with what we get in here. If I put this and it's come out of here. Okay, so where is our thing here? Let's get rid of that, and let's get rid of that, and we're gonna have here to measure our voltage, because we want to measure our voltage to see if we get any voltage drop. Because another thing that we were worried about was to make sure that we don't have any voltage drop on our negative. Okay, so okay, what's happening here now? So that's that. Okay, everything is gonna drop now. We're on AC. We don't want to be on AC. Okay, so that's our 15, and this is our minus 15. All right, now what I'm gonna do, we're gonna connect our BNC, and we're gonna measure our ripple using a proper way, as we discussed before. So we're gonna have our BNC connector here, and if I can put this down this way, there we are. All right, so I'm gonna connect our BNC here. Make sure I don't blow things up. Okay, so where's our ground gone to now? That's our ground, and that's our output. Is that correct? Yes. All right, and let's connect this on our output. There we go. All right, so now that is the right way of doing it. Okay, so we got our minus 15 here, and we need to connect our load. Ooh. Yep, let's turn this off. And that's our load. Is that visible as well? Yep. Okay, so if I put this here, and we can see that. So let's look at the scope, and we'll see what we get on the Scopy. What the Scopy is telling us. Let's get rid of that. And Scope is telling us we got around this, freezing around a bit. Okay, why are you going so fast? Let's boost that up and boost that up. Okay, a lot of this stuff is just background noise. You can tell here, we got some form of switching. Let's see if I turn that off. Nope, yeah, that improves a little bit, but a lot of this I think is background noise. Okay, but if I go down here, you can see that it's not changing much. If I turn it off, we get about maximum, we get about 28 millivolts of ripple. Now if I draw 400 milliamp, you can see that still now it's gone to 30, so it jumps from 16 to 30, so not much is changing. Okay, this is just most of this stuff is just background noise here, and it is not noise from our system. And I can show you what I mean by that. If I just put that in to here and connect it properly, look, you can see it's all background noise. Okay, that's ground. Even that's ground, there is still background noise. So that is not the noise from our system. A lot of that stuff is just the equipment and stuff that I have on here is creating all of that silly noise. So the noise that we get with this type of regulator, this generating negative rail, is much less than the switching type we had. I say it's maximum about 10 millivolt. 10 millivolt is the maximum I see difference. Okay, now let's look at our circuit. Okay, so I discussed that I'm going to look at certain areas. Okay, so what we're going to look at is I'm going to put our ground probe back in. Okay, and let's see what do we get. So if I go to here, we're going to get our 50 hertz. Okay, so that's our 50 hertz. Okay, so basically what our device is doing is stopping all the DC and it's passing AC on the first stage of the capacitor. The big capacitor, 1000 microfarad capacitor that I have, that's passing that. This is, I'm probing the 6800 capacitor, and you can see that we still got around, I say about 85-90 millivolt of ripple on our bulk capacitor. And let's look at the output of our first stage regulator, the Zener regulator. Okay, you can see we still got the same kind of craziness happening. So that's all just a lot of silly noise in the background. Okay, but we got around the same thing. Okay, and that's the output of the Zener. We got the same thing, and this is the output of our linear regulator, but my probing is wrong. I'm using the big lead that I have, the ground lead, so the noise is gonna pass through. This is all you can see. This is just the switching noise. We're not using a switching regulator, so but these are all switching, very similar to a switching noise, as you can see. So that's not it. That's not the way it should be. But you can tell, you can see each stage how the noise is being reduced to the last stage basically. And this is a very easy way of doing basically. Some people might say, oh, there's a lot of parts and stuff to use to do this, but ideally you're gonna have this anyway. You're gonna have your bulk capacitor anyway. You're gonna have your negative regulator anyway on your system if you want to produce a negative rail, clean negative rail. So these and few other capacitors you're going to use down your circuit anyway. The only thing which is added here, maybe you're going to need a kind of a beefy power resistor to bring your voltage down, because this multiplies the voltage and inverts it. And you might need a pre-regulator to bring the voltage down, so you can feed it into your voltage regulator. And other than that, it will work perfectly fine. So what we did, we used a single tap transformer to produce double rail kind of an output. You just got to make sure that your transformer is capable of producing the currents that you basically need from your devices. So this is good for around 1 amp or 1.5 amp. So that can be divided into two, because now we're going to have plus and negative, and each going to draw about 400 milliamp. Is going to be around an amp. So say amp and a half will be perfect headroom to use for your for the circuit. So you can it's a good idea. It's a good thing. I've seen this kind of circuit used in few of the Chinese power supplies, which is floating around on eBay to generate a negative rail. But they don't clean it up how we cleaned it up here. They just got a Zener diode and a couple of resistors, and they're just feeding that into an op amp, which is not a good idea, because you want to clean your signal, clean your power supply, to make sure that whatever's going to your op amp is nice and clean. Obviously op amps got common mode rejection and things like that, but still is a good practice to make sure your power supply is always clean, so whatever issue you have with your circuit is not power supply related. I hope you enjoyed this short video. Well, not short. I hope you enjoyed this video, and this is gonna Basically, this is the circuit we created. Very simple. We kind of used a charge pumpy kind of capacitor diode to invert the voltage, and then we used a Zener diode to pre-regulate, and then our 15 volt this. Obviously you can use whatever voltage regulators you want. You can use a 20 volt, 28 or whatever. You can even put a LM317 and get a variable output, but you just need to watch out your headrooms and your voltages basically. Other than that, good to go. I hope you enjoyed. If you did, please give a thumbs up, and until next video, have a good evening.